Good afternoon, everyone. This is Shauna, and I'm coming to you again today with another tutor check-in. This check-in is for your Math 112. So let me share my screen at this time. This week, you're going to be continuing with your measures of position. We had measures of central tendency and measures of variation last week. This week, we're going to be talking about measures of position. One of those measures of position that you're going to be finding a lot about is the z-score. And the z-score, or the standard score, is going to have more applications later on in this course, especially in chapter 6 and the following chapters after that. But the z-score, maybe you don't hear the term, but you've known about it before. If you've ever taken a standardized test, or if you've been to the doctor and maybe your child or your younger brother or sister, they're talking about developmental milestones, and they'll talk about how many scores above or below, how many z-scores or z-frames, or sometimes we talk about some other things that we're going to be getting to, but those have applications in other fields. And the z-score represents the number of standard deviations that data falls above or below the mean. You need to pay attention to this definition. Notice this X bar in the formula. This is your sample mean here. This is X bar. This is S. This is your sample standard deviation. Pay attention to the symbols. You need to know that. Another measure of position that you're going to be talking about is percentiles. And you hear a lot about percentiles on tests like the SAT or the PSAT. You'll talk about a student scored at this percentile. This is a measure of your position relative to everyone else in a distribution. You're dividing it into 100 parts. Don't confuse percentiles with percentages. They're similar, but they're not the same. Percentiles are the measures of position. Again, the amount of data of at or below you. And you have the formula there for you. Another measure that you're going to be talking about is the percentile rank, not the percentile. So you've been given the percentile. You need to find the number that is in that position. So you can talk about the percentile rank, or you can talk about the percentile. Again, the formula is there for you. Here, don't confuse the location in your list, L, with the actual percentile itself. If I have a list of numbers and I tell you that the number that I want is in the third position in that line, that's just telling me where it is in the list. It doesn't tell me what the number is. So be careful not to confuse the location in the list with the actual percentile itself. So we have z-scores, we have percentiles, we also have quartiles, which are exactly what they might sound like. and deciles. Deciles divide the data into 10 equal groups, quartiles into 4 equal groups. And you have examples of this on the slides, but just be aware that that's what you're going to be looking for. So these are the measures that you want to pay attention to. Z-scores, percentiles, the given number that corresponds to a percentile, and the deciles and the quartiles. That's this section, which is 3.3. Then what you're going to do is you're going to use these ideas to make another descriptive plot. You learned how to make histograms last week. You learned how to make the frequency polygon. You learned how to make the ogive. Now you're going to learn how to make the box plot. And a lot of these ideas, as I mentioned, are used in that project or that endeavor that you're going to be doing. So I'll show you the notes for that section quickly here. Let me bring up the file. Okay, so here we have, and let me make sure I'm sharing my screen with you. Otherwise, I'm not going to see it. All right, so here is section 3.4, exploratory data analysis, the box and whisker plot. Now, the box and whisker plot can be a little bit tricky. It's very mechanical. There's a lot of steps to follow. So the first thing you need to do is you need to calculate the 5-number summary, okay? The 5-number summary is always the same 5 numbers, and you're going to use your calculator to get these numbers, but it's always the same 5 numbers that describe the data. The minimum, the lowest number you have, the maximum, the highest number you have, and the 3 quartiles, quartile 1, quartile 2, quartile 3. Another place where students get confused is with the second quartile. The second quartile has several names. Obviously, the second quartile. It's also called the median of the numbers. It's also called the 50th percentile, P sub 50, as you'll see on the last set of slides, and the 5th decile, or D sub 5. Make sure you understand that these are all referring to the same relative location in the data. P sub 50, D sub 5, Q sub 2, and the median. Okay? And again, the procedures are here for you in the slides. Be sure to pay attention to that. And she gives you a graph of the box and whisker plot here, and she tells you how to construct it. So there's lots of data here for you, and you can read the slides at your leisure. If you ever have questions, you know you can contact us. The other sections that you're going to be working on, that's the end of chapter 3. The other section that you're going to be working on this week is the beginning of the probability chapter. And that's usually the chapter that's a little bit more difficult for people. So the opening sections don't tend to be quite as hard, but sometimes the chapter itself can be difficult. So be sure that you allow time for that. Chapter section 4.1 is just an introduction, but make sure that you understand the introductory concepts in here. And I'm not sharing the correct screen, so let me just back out for 1 minute here. Bear with me for a minute. So when we talk about probability, this is a situation where we have the chance that something will occur. So I'm going to, since it doesn't want to open right here, I'm going to share my screen and show it to you on Canvas. Hold on. I'm going to show you. So this is very familiar. Seen it before. This is your 4.1 sample space, probably. And when you go and look at your sample spaces, let me stop sharing the Canvas screen here. Then you'll see that we have this idea of sample spaces. And what that means is basically all of the possibilities that you have from some sort of probability experiment. One thing that I want you to pay attention to, you'll see this at the beginning of every chapter from now on. And these phrases come up throughout the rest of the book. She wants you to have these phrases down with the symbol. So if you notice, you have the greater than sign, and you have all the phrases underneath that. You have the less than sign, and you have all the phrases underneath that. You have equal to, and all the phrases that mean equal to underneath that. Study this slide, print it if you have access to a printer, or take time to write it down. Keep it somewhere because it's going to come in very handy, not only in the rest of chapter 4, but also in subsequent chapters. The first part of this is pretty straightforward. There are a lot of dice and card problems in here. So if you're not familiar with an American deck of cards, we do have the sample space for you. It's right here. You can find these online, but the more familiar you are with the basic sample space, the easier this will be for you. So be aware of that. We have what we call 4 suits in American deck. And so we have these black things that look like clovers, but they're black. Those are clubs. Then we have these upside down hearts that are black. They're called spades. So clubs and spades are always considered black. And then we have hearts, which are familiar. Hearts are red, and diamonds are red. And every suit, there are 4 of them once again, clubs, spades, hearts, diamonds. Every suit has 13 cards in it. And there are the same 13 cards in each suit. So we have the ace, called the A, or the ace, the 2, the 3, the 4, all the way to 10. And then we have jack, queen, king. Okay, and The jack, the queen, and the king together are called face cards because they have people's faces on them. Okay, so there are 12 face cards because there's 3 face cards that are clubs, 3 face cards that are spades, 3 that are hearts, and 3 that are diamonds. So you want to make sure you understand these terms. These are face cards. Aces are the ones with the ones, and you have the suits here. And anytime, sometimes you'll see rank. So a card of the same rank. That means a card with the same number. So all of the aces are 1 rank. All of the 2s are a rank. All of the 3s are a rank. All of the 4s are a rank, and so forth. All jacks are 1 rank. All queens are 1 rank. All kings are 1 rank. So in every suit, you have 1 card of each rank. So you have 13 ranks. You have 4 suits, okay? 13 cards times 4 suits is 52 cards in total. That's what we call a standard or an ordinary deck. Now, for those of you who may have played cards, you're wondering where the jokers are. Those are not part of an ordinary deck. So an ordinary deck or a standard deck is a deck where the jokers have been removed. Okay, but the standard deck is 52. Most of the rest of this is pretty self-explanatory. You do have the sample space for a deck of cards. We also have the sample space for 2 dice. Dice are the little cubes with dots on the side that you roll and have numbers on them. If you've ever played a board game, chances are you've rolled a die or 2. One cube is a die, D-I-E. More than that are dice. So 1 die, 2 dice, okay? There are some problems in the homework that involve that, but I hope that little overview helps you. So we talk about probability of events. We talk about the types of probability that there are. Dice and cards form what we call classical probability. You'll learn why. And then we also have experimental probability. What happens if you take a die and you roll it 100 times? Are you going to get, 10 6s, 10 5s, 10 4s? Are you going to get the same number every time? Probably not. What you actually get is called your experimental or your empirical probability, okay? So I just wanted to bring these few concepts to your attention. Obviously, you'll have to study them in more detail, but hopefully those hints will help you with the homework. I'm going to come back with another shorter video talking about some of the comments that she made on your last homework assignment, and specifically how to turn in your homework so that you get the maximum points. I don't want to make this one too long, but I hope these tips have helped you, and I hope that you find these little check-ins helpful. Rest assured that I am here to help you, and you are welcome to inbox message me or email or inbox Professor McDowell, and we'll do our best to assist you. I hope you're having a good semester so far. Hope you're safe and healthy. Keep up the good work, and I'll talk to you very soon. Thank you, folks. Bye for now.